with the last presentation presented by Richard McCowan, who is the principal of the Integrated Capital, a group of fintech companies which has developed and licensed the divisia and E2E-FIT platform as a service for family offices, wholesale capital owners, and financial services firms. Richard is a chartered accountant by professions and holds a practicing certificate from the Institute of Chartered Accountants in Australia. He has extensive experience in taxation, business services, business planning, IT services, project funding, and peer-to-peer lending. So I guess I'll just bring up your slides.
Ken didn't send in his bio. Okay, so good afternoon, everyone. And not sure if this is the graveyard shift or the light at the end of the tunnel for everyone. So either way, we'll get through it. But Ken and I were thinking it may have been the sort of the headline act in shows normally the last one, but we're not sure. But don't disillusion us now. So I'm Richard McEwen, and this is Ken Miles, and we're part of the team at Integrated Capital, Integrated Capital. We're a fintech company. We're based in Brisbane. Essentially, we provide systems that come with financial capital backing for financial transactions. We built a non-bank lending platform using, amongst other things, distributed ledger technology. And we'd like to just share our thoughts and experience on the phenomenon that's become DeFi and what might lie beyond that. So, what is DeFi? DeFi is short for decentralized finance. I guess you're all familiar with the rise of decentralized finance and the value that is currently on those platforms. But really, it's essentially using fairly traditional finance concepts or ideas, which deals with locking something of value into an agreement for some kind of benefit or reward, and you may well have to forfeit that security or the collateral that you've put up. So it's a very old concept, been around. That's really finance. So essentially, DeFi is using basically those principles, but it's using really using distributed or digital assets and agreements, and the terms and conditions of which are enforced by smart contracts, which we've just been discussing, potentially have some flaws. So, but it's quite difficult, I find, to keep up with actually the value and the scale at which those the DeFi contracts and the DeFi platforms are now operating. I think we did a talk last year earlier this year, and I think it was something like $80 billion was on there. When you look at it now, it's $107 billion are locked in DeFi contracts. So I've basically got that from something called DeFi Pulse, which has a very detailed method of including and calculating really what it's doing. They are the criteria to assess the how they measure that the index and how they measure the 104 or 7 billion as it goes up. That same index also records the amount of value that's on some of the different protocols, and in order, I think it was the first three. The examples of those DeFi platforms would be Maker to governance token, and also allows the issuance of the DAI stablecoin. Curve's a decentralized exchange for stablecoins. It uses automatic market maker. Now, this was previously called ETHLend, I think, when it started. It's now called ARV. It's a decentralized finance protocol that allows people to lend and borrow cryptocurrency. So the list goes on. There's quite a large list of those providers. I suppose if you go back to that list, if you look at what's not included, the tokens that aren't included on there, they don't include anything called a security. They also don't include tokens that lock, mint, and have other patterns that would significantly disadvantage passive holders. They're trying to exclude, thankfully, Ponzi's characteristics, which I suspect some of them may well be Ponzi type schemes. And they're also excluding tokens that are primarily for entertainment. Similarly, leaves out wrapped tokens, tokenized derivatives, synthetic assets, tokens tied to physical assets, and tokens that have claims on other tokens. So really, that 107 billion, like, it does exclude a lot of other stuff that's there. So the question then is, what are the regulators really doing, and what are they sitting back and, are they just watching this all happen? I think regulators being regulators, it is their role. So I don't think they are going to let it happen, and they're certainly not doing that in some countries. And I think as they get their act together, they will start to try and regulate this space more. They're regulators and central banks, the central governance. Really, they have a job, or their role is to control monetary policy and monetary issuances. So they would see and do see some of the DeFi projects as being interrupting their sovereignty, really. So people like China, I guess you can see what they're looking to do, that they'll make it illegal, and then they'll make way for their own central bank digital currency. The US, looking at their regulations, they're looking at trying to get operators and exchanges. They'll try and control them and potentially tax them. So, like, in my view, the regulators and the central authorities are just going to look more and more at these products. Particularly the US, for example, is looking at anything that's a security would have to be regulated. They don't like unlicensed trading, holding, tokenizing derivatives. Derivatives probably caused the last global financial crisis, so I don't think they really want to see that replicated again in any form. So I do think that the regulators are definitely concerned. But I think the follow-on, and the thing that is where the big sort of next step from DeFi, I think, is when you start bringing in real-world assets like property and land and securities, and you start applying the DeFi concepts or the platforms as they're built now. You can bring in tokenized real-world assets, then that's really going to lead to a much more broader adoption of the concepts of DeFi when you have the real-world assets in there. So that leads on to what we do, and so we've really waded into, I guess, real world transactions on decentralized finance. So our platform's called divisia E2E5, and we're really, I guess, our goal has been to try to eliminate friction in the lending. Like essentially we do private lending, we disintermediate banks, and our platform as it has evolved and developed to what it is now, like we've essentially funded 156 million in private lending transactions. They have been secured against real world assets, basically land that's been subdivided, and that's been turned into nearly $250 million worth of finished land, so 663 lots of land, and currently there'd be about 26 million on that platform as private lending or private credit transactions. Now that's just in and around Brisbane, really. That's not even very broadly spread. So we've run that, and we are running that, and Ken will talk about how we're running that. But that does run on private distributed ledger system or consortium chain. And I suppose a couple of concepts why we're really, I guess, the same, but we're different in that we look to try and use distributed ledger to what's the smallest network that we can run that will get benefit from running it that way. And because one of the important concepts, one of the concepts that has been around for a long time, but it's really probably never been able to be implemented properly, is it's just simply division of duties and building into a transaction, a financial transaction, a legally binding contract, is really building into it how that will run and how can you build controls into that so that you can trust the way the transaction itself has been run. So really we've built a platform that it really maps and encodes those terms and conditions that are in the legally binding contracts, turns them into a smart contract that runs on our distributed ledger system. And I guess interestingly, Adrian, it's good to follow on from your presentation, but it's a little bit in that when we're dealing with, actually always there's a legally binding contract under it. Like you can go to court, people can be sued, but I guess we're dealing with one type of contract, so we're able to run that in a set of processes that are pretty similar each time, but really we're just taking the relevant parts out of those contracts. We're putting it into an end-to-end process that says, this is how you draw your money out. We'll get a certifier or certified. It's all run on the platform. So it's basically predefined steps from contracts that I guess we can influence because we say we'll use a certain lawyer to prepare them. But once you've got that underlying structure there, the software component, the software steps and the procedures in there do follow. So I guess if we had to do a different type of contract, it's a bit more retooling. But Ken will talk about what we're using to do that. But so it is interesting. You don't have to have really big networks to get benefits from a decentralized finance, because everyone can see what everyone else is doing, and by it just essentially keeps everyone honest in a way. So it's a very old concept that that it's finally you can embed that now into how to run transactions. So with that, I will hand over to Ken Miles, who will take you through the specifics of how we're doing that on our current build. So take it away, Ken.
Okay, thank you, Richard. Richard's the fin and I'm the tech. So I thought, we're going to talk about technical implementation. I'm going to talk about the distributed ledger technology, the architecture, the enterprise security, deployment operations and challenges that we've had running the technology. Okay, so the technology that we use for the distributed ledger is Hyperledger Vesu. We have our smart contracts that immutable ledger to store the transactions that are happening. So the changes, store the contract details of the loan and transactions that happen against the loan. There's repayments made, interest made on the loan repayments. So that's all stored in the smart contract. It has a multi-tenancy distributed consensus protocol. It's got it's based on Ethereum with JSON RPC APIs. It has an Orion privacy manager that encrypts the state of the private transactions. And we have a privacy group. So all the parties that are involved in the smart contract, they form a privacy group. And we'll have a look at how that's sort of structured a bit further on. Okay, I thought I'd define the specific type of chain to make it a bit more clear. So we've got mainnet Ethereum, which is the public chain. You have a private chain where it's sort of one owner of that chain. And then we've got a consortium chain. So where we've got sort of multiple parties will run their own node, run their own Ethereum node. And we have every person essentially that is involved will be either have their own node or they can have multi-tenancy within that one node. So you can see all the properties of the different types of chains there. Okay, so application architecture. So as a part of the structure, we've got an application at the top. We've got distributed applications. We've got an API web app. We've got a block explorer. We use Solidity for the smart contract. The tooling we use for like credential management, for storing the PKI infrastructure, policies, cryptographic keys, certificates. We use HashiCorp Vault. And I guess, we've got privacy concerns, permission concerns on us, like enterprise level, features and trust and with reliable software. We've got for certificates, TLS certificates, we've got whitelisting and known certificate authority. There's sort of two privacy models, I guess, where you can, when you're encrypting the transactions, you encrypt them on the public chain, or you can store the encrypted transaction on Orion. So that's what we're doing, being a bit more, I guess, paranoid about the encryption or the level of encryption and data hiding. So we're not doing on-chain based stuff. We're doing it on the enclave, which is Orion. Okay, so everything else is pretty, I guess, standard there. Okay, so this is a sort of like high-level view on what we're doing. So we've got a DMZ there with custom software. We've got a web server API for our divisia platform. We talked already here, we've got a middleware. So the middleware abstracts the implementation. So in the future, if we want to try a different blockchain, we can just substitute that component out if need be. I doubt we will, but it's one of those things. We've got our secret store there, so that's the HashiCorp vault, where because we've got this Ethereum secure proxy that we've developed because of the high level of security we have built in from mutual TLS authentication. So because of that, the Block Explorer is a React app. So and it's running on the person's browser. So getting mutual TLS authentication working there is just not going to happen. So we have to implement this Ethereum secure proxy. And then we've got Besu and Orion nodes in that configuration there. It's kind of like, I don't know if it's that easy to understand with all the lines, but all the Besus talk to each other and all the Orions talk to each other. And the pairs of Besu and Orion talk. There's no crosstalk between them. That's why I sort of colored the lines rather than drawing more. Okay, so I've kind of explained that we have this middleware service that we use from our platform to talk to the chain. Look about smart contracts and stuff. So that's just a quick screenshot of our ledger. I've talked about enterprise security, so our secret vault. I've talked about, we use mutual TLS authentication. So the regular form of authentication is, you go to a website, it's got, you got a little catalog with the SSL. That's just server-based TLS authentication. So we want to actually authenticate the client and the server to make sure that both parties are authorized to perform operations on the blockchain. So, so each component within that, other than the Block Explorer, so I guess, the green lines indicate the TLS from the middleware, the proxy through Besu and Orion, they all use TLS, even internally, to talk to each other. So that is quite complicated. So all are using latest TLS 1.3 standard. And also all the SSL certificates are rotated periodically automatically. Because I didn't want to have to deal with someone leaves or someone with access to a system. I didn't want to have to change it or have any problems with any downtime, I guess, or forget the procedure because it's quite complicated. So I guess I wanted to highlight the emphasis on security is that there's no, I'm sure as well, there are no second chances. I guess you have to try and make sure everything is as secure as possible. Perform rigorous testing, testing networks are your best friend. Okay, so when we're the client, I guess, when they're looking at our system, they just get a few block hashes, don't really understand what's going on. So under each contract and under each individual transaction that they're performing, there'll be an address. They can then visualize that in the Block Explorer. You can see the cryptographic hash. You can see a lot of values. I guess the point of that is it's immutable and it's not going to change. And I guess there's some comfort in that. Okay, so deployment. we use CI/CD with GitLab. All our images, our development images are built in GitLab using Docker. Production access limited. Provisioning of all our services and all automatic server development. It's stood up the exact same way in development as it is in production. The Docker containers themselves are immutable and predictable. All our provisioning configurations, like I was saying before, the key pairs are all stored in HashiCorp Vault, and that's all automated. So if I need to blow it away, I can quite easily set up a staging network. Okay, so and we use this program that integrates with HashiCorp Vault called Console Template that takes the artifacts in that secret store and generates all the different formats that are required, because there's quite a few formats. So yeah, you can create your own plugins for it. So I've had to create a fair few plugins. Okay, so operations. What issues have we had? We've been running this for about 7 months. It does generate quite a bit of data because it's constantly generating data. So we've generated about 24 gigabytes of space, and the amount of contracts and transactions is quite low compared to the space needed. If you're thinking about it as a traditional database system. The TLS authentication issues can be quite hard to troubleshoot because we're going through multiple levels. Now it's being proxied through a few levels to go from the middleware to Vessu and Orion and back again. And each party is authenticated. And we have a problem with HashiCorp Vault when we're cleaning up after ourselves. We could deny of service ourselves, pretty much bringing the system down. So we have to fix that and look out for that. Okay. So challenges from a development point of view, it's quite slow because we've had to, if we want to replicate the whole environment, we have to bring up all the nodes on a laptop. So I bring it up on my Mac laptop, and yeah, the fans are going pretty hard to do so. I guess it's hard to find good practical examples of the implementation. A lot of the examples you see out there are quite novel, specifically with Consortium chain and enterprises. I would say, well, there's a lot of different programming languages and technologies we're using so Brisbane and Orion are written in Java. The middleware is written in Node.js and TypeScript, and our proxy is written in Golang. So all of those different programming languages have different ways of interacting, different libraries, and different ways of handling TLS authentication. Like I've had to read the OpenJDK TLS authentication handshake agreement to work out what was going wrong. So, for example, one of the problems I was having. The cryptographic primitives, so how you store your keys, and the key stores are not very consistent between different languages and even in between Vessu and Orion. So essentially you have to re-implement the way you are handling these primitives. A bit of a challenge. So I guess it could be a lot easier, I guess. And it probably will improve over time.
Thanks, Ken. So that's what's next from our point of view. We're pretty central in the administration of that. We're actually a party on that transaction. Ideally, though, we would like to have all the parties to a contract really, us not to necessarily be the administration in there, and perhaps get those parties represented in a decentralised, autonomous organisation or a DAO. We are going to look at that. I mean, companies, for instance, in one state, I think in America, are now got a DAO, ability to be a DAO. So
State of Wyoming.
Wyoming, yes. So that's and it's just like shelf companies. Most of these parties in these transactions are special purpose vehicles, proprietary limited companies. So you could easily, I could see that we could, down the track, offload some of our administration to those, which then the parties themselves control, which then becomes even more trusted by them. We're using a ERC20 token, trying to use it for behavioural economics, really, points and rewards system, whereby pay your loan back, you'll get free or reduced platform license. I mean, essentially, our platform license is 1% of the funded transaction, which then runs everything from start to finish. And compared to perhaps the trusts and a number of other providers, like they're probably charging both parties, lenders and borrowers, the equivalent of between 3.5% or 4%. So you can really cut away a lot of the transaction costs and friction out of it when you get a borrower and a lender getting together. So that's just one type of transaction that really we started with. We were in that space, in the fin space, so we put the tech on. But I think you could, as you got better at how the technology plays out and how we run the end-to-end steps, I think you could go vertically across different types of contracts. You could actually do ESG kind of contracts and monitor who spends what on what, and you've got a complete history of all those transactions. There's a whole lot of, it's really, essentially, it's anything that's a financial contract that goes over a period of time with multiple parties, you could run in the same way. So we're busy just doing private credit, but ultimately we'll move on to some of these other things. Again, always with legally binding contract. So basically, yeah, that's it. So I can open that up for questions. Anyone? Ken or myself?
I have a question about your requirement.
Yeah.
So you were showing the requirement for 4 nodes. Are those 4 nodes managed by different parties? Are they distributed?
So currently they're managed by us, but the intent is they would be managed by another party. We've got 5, not 4. So that needs to be updated. We've got one for the express purpose of auditing. So an auditor would have their own node sitting in their own office there somewhere. And then they would have their own tools and tooling developed in conjunction with us to be able to constantly audit and monitor the consortium chain. Yeah.
So the plan is that they would be able to run it on AWS or Azure and run it in their office and have all the transactions. So we're a Microsoft partner and we're running that as Azure. Currently, it's all on our private cloud. Yeah.
Do you have any plans to scale up? Because 5 nodes EOP is a bit steep because only probably 1 node failure. We need 2 nodes.
Yeah, well, 1 misbehaving. Yeah. So yes, we have 5, but so that's 2. But actually, it's not 2. But yeah. So we can have as many as we like. Just down to, I guess, what the needs are of the business and the people involved. So I don't know what the limits are. That was the question, but yeah.
Yeah, because as you increase the number of nodes, that's going to become slow. you need to have all your systems.
Well, I guess Emily, you're remaining that, like, yeah, so I guess technology scales is using Ethereum.
But it's also a different consensus protocol, so it's IBFT. There's a new protocol, QBFT. I think QBFT only might be able to configure it to generate blocks. I'm actually going to need to get going. So,
Okay.
very good talk. Very interesting. And I've taken a photo on the feedback about
Yeah, good.
issues
Okay.
with this. Who knows, maybe someone will reach out and say, yeah.
Okay.
Nice.
All right.
First a comment from the point of view of BFT, there's only one general situation. But have you thought of running it, your smart contracts, on the public chain, given that you are keeping your data private and online? And pursue annual rewards program? So that's only valuable to you, but there's on the public contract, that's your real fee.
Have, but I think the costs are just a bit prohibitive. Ultimately, I can see that's where it will go, but at this stage, we're just running it the way we're running it. And in essence, you know, the people that have got the capital on there running those transactions, they're quite naive technologically, so they just want their money back with a return, essentially. So they don't really care. So yes, we have thought about that. We'll monitor that and could potentially do that. Yeah.
Well, we might
Okay.
thank our speakers, and if there are more questions, follow up with them after the official session. So that brings us also to the conclusion of the day. Thanks everyone for joining. Thanks to all the speakers. I want to thank the organizing committee for SDLT, particularly Ali and Peter, who have done a great effort in making things happen in the last few weeks. I think the conversation was really interesting. We heard some very diverse talks from both the legal aspects, from the technological aspects, and the application side as well. And I look forward to seeing the conversation continue in future events such as this one and others. So thanks everyone, and have a great day.